So, hello. I'm going to present the Fermi paradox with Justin Fisher and Victoria Nitness through recordings. All right, so for a brief introduction, there is a really high probability of alien life elsewhere in the universe, according to most scientists. The Drake equation and other Drake-like equations suggest that alien life should not be so rare as to us being unable to find it, and microbiologists have actually shown that RNA can be produced out of the primordial ingredients on the primordial Earth. Nikolai Kardashev and Freeman Dyson briefly speak about superstructures that alien civilizations may build, both arguing that civilizations would naturally progress, requiring energy levels on the magnitudes of their own stellar output, requiring the constructions of a Dyson sphere or Dyson swarm, a colossal collection of satellites orbiting a star and collecting its energy. These Dyson swarms actually played an important role in the early search for alien life at SETI due to their ease of detection. Mathematically, Kardashev proved that the existence of these Dyson spheres, and he actually went as far as to state that there's a 0% chance that we're alone in the universe. However, after 60 years of searching, no Dyson sphere has been found, unfortunately. In fact, no alien life whatsoever has been found. This contradiction between mathematical predictions and what we observe has puzzled scientists for decades and has been aptly named, sort of, the Fermi paradox. The subsequent lack of observation of alien life is titled the Fermi observation. Since, as far as we know, the problem of why we're observing a lack of alien life is actually kind of hard to solve, almost impossible to solve, because we have a lack of data on said alien life, there are a lot of solutions that could work, but that don't necessarily agree with one another, such as the idea that all aliens are in fact Hungarians. I mean, that one doesn't really make sense in general. But there's also a lot of solutions that depend on a human-centric point of view. So that's like on social interactions, on our warring nature, which is a bias it's almost impossible to oversee because we can't really predict how other civilizations may grow. Due to the uncertainty in the Fermi paradox's solutions, instead of focusing on a single solution, this report will cover a few solutions that have yet to be disproven, and a larger solution that states to dissolve the Fermi paradox.
Some experts would suggest that the scarcity of observed evidence for extraterrestrial life could be due to there being no more extraterrestrials to observe. As we know, the universe is old, very, very old. For all we know, we may be the first civilization to ever exist in the universe's life, but it's also possible that we may just be one of the last. More specifically, alien civilizations may have existed in the past, but for some reason, most, if not all others except for us, have gone extinct. The universe may have become more unsuitable for life as it aged, resulting in the natural extinction of life. Of course, that is the natural extinction of all life that does not exist on Earth. We could also consider the possibility that a dominant alien civilization could have killed off most other life and then eventually died themselves. Conversely, what if aliens are actually alive like we expect them to be? What if they're actually all around us, but we just can't see them? More than that, what if they can see us? This idea is referred to as the zoo hypothesis. The zoo hypothesis suggests that alien life intentionally avoids communication with Earth to allow for natural evolution and socio-cultural development, and avoiding interplanetary contamination similarly to people observing animals at a zoo. Many other solutions to the Fermi paradox make the assumption that extraterrestrial life want to seek out other alien civilizations in the same way that we do. However, the implications of the zoo hypothesis are particularly eerie, as it would suggest that not only have aliens found us despite us not being able to find them, but that they are also observing us from a distance. It suggests that we are being studied. The zoo hypothesis also suggests that these observant alien civilizations may be waiting until humans can evolve to meet their social standards, like technology and intelligence, etc. Or They might withhold contact until humans force contact upon them, possibly by sending a spacecraft to planets they inhabit. The hypothesis assumes that life will always exist and further evolve whenever the conditions for life are met. It also assumes that intelligent life will naturally try to maximize the potential diversity of a system. This is essentially, an example of this is evolution on Earth, where we have a diverse set of species, all coming from one common ancestor. The zoo hypothesis suggests that this is a result of intelligent life trying to diversify its system. One common critique of the zoo hypothesis is that it wouldn't be very likely that all alien civilizations collectively agree to observe humans without making contact. Additionally, it would only take one civilization, or even one alien if they make themselves noticeable enough, to completely dismantle everything, because then we would know that aliens exist. So one issue that I have with this criticism is that it assumes that alien civilizations should necessarily interact with one another in the same manner that groups of humans do. An example of this would be that governments, like the governments of various countries, have a hard enough time coming together to agree on certain things, right? And an alien civilization wouldn't just be analogous to a government; it would be analogous to Earth, like all humans on Earth. So if our governments within the world have a hard enough time agreeing on different things, how could we expect entire worlds of aliens to come together to agree to observe humans without not even one making a mistake, tripping up, and I guess doing something that would signal to us that there's a potential for life to exist outside of Earth? So I would say that the assumption that aliens necessarily are going to behave in this way is possible, since we don't necessarily know how life should, how aliens would interact, or I guess living beings would interact with one another outside of how humans interact with one another, since we don't have any evidence for this. But I would say that it would be hard to concretely say that they should interact in that way when we're making that assumption based off one single data point. So that's why I would kind of say that criticism is kind of soft, but it is still a very common criticism that is made about this hypothesis. Nonetheless, I find the zoo hypothesis to be very interesting and quite scary, to be honest.
So, another proposed solution to the Fermi paradox is that life on Earth happened by some sort of fluke, which is never to be repeated. Kind of like how the Big Bang happened once at the beginning of time, and nothing like that has happened ever since. However, the chemicals present in cosmic dust that would support life are abundant, and with so many habitable planets out in the universe, it's safe to assume that there are other forms of life out there. Unfortunately, or maybe even fortunately, any form of life has yet to be detected. Even if other life in the universe does exist, we know how harmful the universe can be. For example, black holes destroying anything in their vicinity, galactic cannibalism, which is just galaxies colliding together, forming a completely new one. And finally, gamma ray bursts. It could be very difficult for a planet to host any sort of potential life and protect it from the dangers of the universe. For example, a gamma ray burst close enough to a habitable planet can destroy the atmosphere, pretty much wiping out any life that was once there. The ongoing search for life that has evolved similarly to humans' social and technological life has the physicist Stephen Webb, author of If the Universe is Teeming with Aliens, Where is Everybody? Asking questions. Why should we expect advanced life forms like us to be somewhere in the universe? There could be other senses that we aren't even aware of, more beneficial to the beings on other planets. Like Webb says, it's only arrogant to assume that if there are other creatures, they must be similar to us. The question we keep asking ourselves is, where is everybody else? Why have they yet to communicate with us? Perhaps it's because we keep searching for life with high intelligence. Nevertheless, why are we assuming intelligence is so common? Based on our observations of intelligence from the simplest forms of life, the results indicate that human intelligence is the most evolved. Simple life forms, such as fungi or bacteria, are nowhere near the level of human intelligence. Humans are the only species in the animal kingdom to have evolved this type of high intelligence, but millions of species thrive without it. We are searching for intelligent life forms that have both the resources and the means to use materials and turn them into tools. Not only must they be conscious enough for the tool making, the life forms must be developed enough to have a formulated language that humans would be able to understand. We're basically looking for another, more advanced version of ourselves. There's no reason to assume that other life forms beyond Earth must exhibit similar characteristics to humanity. All the other species on our planet have managed to survive just fine without being as evolved as us humans are.
The final solution, proposed by Anders Sandberg, Eric Drexler, and Toby Ord from the Future of Humanity Institute in their paper titled Dissolving the Fermi Paradox, attempts to debunk the Fermi paradox itself instead of creating a solution to it. Their results can actually be seen as an answer to the Fermi observation, which, as you may recall, is the observation of a lack of alien life. So let's begin. In their abstract, Sandberg et al. State that the Drake equation and other similar equations are nearly always used with point estimate variables, with varying results spanning up to 8 orders of magnitude between papers. Using ranges on these equations, their models show that the probability of alien life is actually relatively low, effectively dissolving the Fermi paradox. So the article has 3 main results. The first result states that a proper evaluation of scientific uncertainty dissolves the Fermi paradox by finding that it is not likely that we are alone. One of the key discrepancies that fuels the Fermi paradox is the difference between the number of expected places alien life should emerge and the complete lack of any observational data at any sites. The Drake equation is very closely tied to the Fermi paradox because of this very reason. The Drake equation estimates the number of detectable or contactable alien civilizations in the Milky Way, or in the universe. The result being, according to most research as of now, a lot of alien civilizations. It turns out that the Drake equation has been noted to vary strongly according to the will of the authors doing research with it. In fact, it tends to vary between 8 orders of magnitude according to the scientist you ask. However, the authors of the paper have found that 8 orders of magnitude is actually much too little of a variation, and it is in fact a show of overconfidence. The authors go on to say that the use of point estimates instead of ranges for the variables in the Drake equation has been responsible for the puzzlement about the Fermi paradox, as the results pretend to be without uncertainty. So, the authors of the paper use a basic model representing 3 variables with a value between 0 and 0.2 multiplied together to represent an example of the Drake equation and point estimates. If their uncertainties are tracked, which means if the ranges are used in the calculations, there's a 21.45% chance of no aliens being the outcome. However, if the uncertainties are not tracked, the outcome will show values that are not necessarily accurate. Tracking uncertainties in the variables in the Drake equation, the authors reached their final result. So using point estimates in the Drake equation frequently generates numbers of alien civilizations that would produce a Fermi paradox. So tracking uncertainty shows that there's substantial probability, 38%, that there is no alien intelligent life in our observable universe, and a 52% chance that we are alone in the Milky Way. So the second result uses a combination of the Drake equation probability that we are alone with the Fermi observation, the lack of observation of alien life. Accounting for uncertainties in the possible detection range of alien civilizations, the probability that we are alone in the galaxy increases to between 53% and 99.6%, depending on the type of evidence, and the probability that we are alone in the universe increases to between 39% and 85%. The reason for this variation in percentages is because it's because of how we interpret the lack of radiation signals in our galaxy and lack of interstellar settlements in our galaxy and nearby galaxies. The authors also note that these results assume that our ability to recognize alien civilizations lacks systematic error. However, even accounting for the possibility of this error changes their results negligibly, unless one assigns the probability of error to be very large. So the third result states that the aforementioned galactic killers in Justin's introduction is largely unfounded due to the low probability of the alien life term in the Drake equation being in the past and not the future. Therefore, the observation that life is rare does not necessarily mean that we will be hunted by aliens. It mainly just states that the formation of life itself is rare because it's in the past, because the low probability is in the past. The Fermi paradox is interesting as it draws in those who study it. Its endless solutions can prove frightening and entertaining to read about, and has caused much speculation in the scientific world. An interesting possible solution that we evaluated are the idea of galactic killers in Justin's introduction. That is, a massive super civilization of aliens that wipe out any trace of aliens that they find. So all aliens are either that one civilization that may have died or are in hiding. Another idea that Justin talks about is the zoo hypothesis, wherein we're actually being watched by, or we're infiltrated by aliens already, and they're simply waiting or watching. Another possible solution is that we're simply searching for the wrong thing. Intelligence is quantified according to our perspective for us, but it may be different for other alien civilizations. So we may just be simply looking for the wrong intelligence. Finally, there's also the solution that is the dissolution of the Fermi paradox, wherein the probability of humans being alone in the universe and the galaxy is actually quite high from a recalculation of the Drake equation using uncertainties instead of point values combined with the Fermi observation. However, this article attempts to dissolve the Fermi paradox. It is in fact simply a solution to it. It explains why we have not seen life, though an answer to the call of the Fermi observation. In the end, we may never know the answer to the question, where are they? But according to the dissolution, they're probably extremely far away. Thanks for listening.